Sıradaki konuşmacımız Commscope'dan Juergen Niethammer. Kendisini alkışlarınızla sahneye davet ediyorum.
Good afternoon. My name is Niethammer. I'm here from Commscope. We are a global market leader in data center cabling solutions. And the topic I have brought with me today is AI. Of course, everybody talks about AI today. We're looking more in my presentation in the challenges. Of course, covering the cabling challenges as well as the power that the colleague before was talking about. But before I do, I will try to explain you why AI is such a huge hype. Of course, it has the potential to change the society. Corporations, enterprises are looking into using AI to become much more efficient in several areas, in several business areas. From a supplier perspective, it's this what drives us. So what you see here is the market growth that is expected because of AI from here 2023 to 2030. And you see we have an annual growth rate of almost 37% from 150 billion today to 1.3 for 5 trillion. Sorry, I'm German, and this is the abbreviation for a billion in the German language. So it's a very, very huge market, and Goldman Sachs is saying that by 2032, it can be that the AI business is valid of 2% of the GDP of the United States. So that's a massive value. And as it will be built, the AI infrastructure, you see it here. You see in blue, that's software. You see in orange, it's hardware. And in black, you have the modeling. And you see there will be huge investments into the infrastructure and the hardware until 2033, that's the prediction so far, and then the infrastructure cost will go down because then the networks are there, all the infrastructure has been built, and from there on it will be a software spend. From there on we will all hopefully benefit from the capabilities that AI will give to us. I'm not going into philosophical discussions about if AI is good or bad and how we will use it for. The future will show. I'm just thinking there is so much. I mean, I'm in the industry, believe it or not, for 30 years. And I remember still in 1995, fast internet came, 100 megabit, and the people were saying, oh, we will never use that, never. Yeah? And now we talk about, and you will see it later, we talk about 400 gigabit, 800 gigabit as a transmission speed. And I have never seen, as long as I'm in this industry, such a, you can really call it a gold rush mood that is in the industry because of AI. AI will change the data center. Here on the top, last graphic, you see in green the AI servers and in blue the traditional general purpose servers. And you see that, or you cannot read it, but this is 2025. They predict that in 2025 there will be more AI servers installed in data centers than regular general purpose servers. I don't believe that. I have my own way of reading those things. It will come like this, but the way I read it, I just moved the timeline by 2 to 3 years. So it will probably not be in 2025. But it might be in 2027 or 2028. So the trend will come. The trend is correct. Maybe the time is wrong. How is AI coming into a data center? On the left-hand side, you have a traditional data center, a cloud data center or an enterprise data center. They all look the same way. They have the interconnect that connects the data center to the outside world. And then you have the spine and leaf network, and there are the CPU servers connected to this. This is the structure that almost every data center has. When we talk about AI, on the right-hand side, suddenly we have two networks. We have the existing network on the front, on the top. In the new that is called the front-end network, because that is providing the customer interface. So your requests come in from the top to ChatGPT, for example, and then it goes all the way down to the AI part. And the AI part is the so-called back-end network. And you see, it's a completely new network, which is called, very often, AI cluster. So it's basically a new network that is coming in addition to an existing network in a data center that handles all the AI requests. And the reason for that is, for AI you need very, very high-speed processors, and regular CPUs cannot do that. They are limited in cores, in the number of cores. They are limited in the ability of do parallel processing. So the world of AI is the world of so-called GPUs, graphical processing units. They actually come from the gaming industry. Maybe some of you know. You know, there was NVIDIA, the leader in AI, started, with having graphical cards in your PC, to expedite, to accelerate the graphics to offer high-speed gaming. And now they are the market leader in AI because they have the ability, or they did, bring the GPU performance into servers, and they have a much, much higher compute power than regular CPUs. So the way it works, so if this is a server, an AI server, it has a CPU, one or two CPUs that connect to the front-end network, and they have several GPUs that connect to the back-end network and do all the work for the AI. When we talk about AI networks, a good approach is to say everything is times 4. It will be even more, it might be in 2-3 years times 8, but so far, and I will explain every topic here, you have 4 times more power, you have 4 times more fiber in a data center, and the network speed is also increased by 4. And we will look into everything, into every topic here. AI is very power hungry. You have heard that from the speaker before. It's probably not good to read, but what this is saying, it's a prediction from Deloitte. It's saying that from 2025, the data center's electricity consumption compared to the overall electricity consumption will increase from 2% to 3.7%. That does not look very much, that does not sound very much, but it's an 85% increase. So in the next 5 years, there will be an 85% increase in data centers' electricity consumption. That's unbelievable. And it's, 40% of that goes to cooling, 40% goes to power, so that equals somehow. And this is why. Now we jump a little bit into NVIDIA architectures and NVIDIA products. So they have NVIDIA has an AI server which is called NVIDIA DGX H100. It's written here. Yeah. And this server has 8 GPUs, 8 graphical processors, and in total that one of those golden or brown blocks you see here consumes 10.2 kilowatt. That's massive. So that means you have 40.8 kilowatts per rack. And what they have here is a configuration they call a scalable unit that has 128 GPUs. And you see when you put that together, and you have, let's say, 41 kilowatt per rack, plus the management racks with all the switches, you end up with a heat load and power consumption of 358 kilowatt. In a traditional data center with air cooling, that's not possible. Yeah? When you go to a co-locator today, he can probably give you 10 kilowatt. Right? I know that 10 kilowatt is already in an enterprise data center. 10 kilowatt cooling and power consumption per cabinet is high for a regular enterprise data center. Here we have 4 times more. The next generation will have 8 times more. You have seen that in the presentation before. So the time, I think, from air cooling is coming to an end, because all these high cooling loads you can only get rid of a kind of water-assisted cooling, no matter if it's a direct-to-chip cooling. Direct-to-chip cooling means you have really pipes going into the server and they cool the surface of the GPU, or you have an immersion cooling, which is a kind of oil bath where you put the servers in, yeah? Or you have a backdoor, an air-assisted liquid cooling. You have a backdoor that functions like a refrigerator and blows the cool air coming from the water into the cabinet. So this is the future. And as I said, this is just the beginning. The newest generations of the NVIDIA servers and the configurations that they are using, they consume much, much more power. So that was power. Now we talk a little bit about cabling quantities, number of fibers. You remember that was the second point here. A traditional server has two connections to the network, A and B. With an AI server, every GPU of that server has one connection. So that means in the case of NVIDIA, this server has eight connections to the network, only to the back-end network. Of course, they also have connections to the front-end network. Plus you have management, plus you have storage eventually. So when you look into this, and this is all taken from the NVIDIA papers, what they say a superpod is 4 times a scalable unit. You remember a scalable unit has 128 GPUs, and you have 4 of them, and then you have 2044 cable just for the network. 2044. That's massive, because the connections from the GPUs, they go to the leaf switches, the spine switches. It's really much, much more than you normally have in a data center. And it gets worse if you have a real large data center with more than 16 scalable units. You see that here on the top. Yeah? Then it starts to go exponential. We have, maybe you have read about Colossus. That's a data center that xAI is building, Elon Musk, in the US, that has 4 phases. Each phase has 25,000 GPUs. 25,000. And here this goes until, this table goes until 16,000, and then you already have almost 50,000 cables in that data center. That's really massive. And it costs a lot of money, because one server, guess what a server costs? One AI server, DGX 100 from NVIDIA, I tell you, probably $250,000. It's massive what they invest. I have to speed up, sorry for that. That was power, that was quantity of fiber. The last thing is bandwidth. You see here on that table that this is the speed in AI clusters. And remember, well, my words shift the timetable a little bit, but I predict in 2 or 3 years from now, it will all be 800 gig with 1.6 terabit knocking on the door. So we have that speed in the data center today. And what that means is when you look at 800 gig and 1.6 terabit, how they will be defined, we see a move away from MPO8 and MPO12 connector at the transceiver interface towards MPO16. So you need 16 fibers to transmit the 800 gig, for example. Why? Because you have 2 fibers that use 1 gig, that's a lane. And if you want to have 800 gig, you transmit 8 times 100 gig. So that means you need 8 times 2, 16 fibers. This is why an MPO16 architecture is the most future-proof data center architecture for AI. And it's there, I mentioned it. This is from NVIDIA. They say in 2025, remember my timeline, maybe next year or over next year, they will go to 1.6 terabit for each GPU. And that's the number of fibers for a connector, but what we also see is a change in the connector interface. Normally, if you're familiar with MPO, an MPO connector multimode has always a UPC finish, that means ultra polish physical contact finish, so the two fibers, they touch each other, and the polishing is flat. In single mode, we use angle polish. Angle polish means the two fibers are polished like this. You see that in that picture over there, APC and face. And when it comes to the PAM4 coding that is used with these high speeds, 400, 800, and 1.6 terabit, you need MPO16 APC even for multimode. So no matter if it's multimode or single mode, MPOs in future for future-proof AI networks will be MPO16, and they will be angle polished. You can have a look at that in our booth over there, just here at that coffee stop, where we have a lot of our products that we have specially made for AI networks. Thank you very much.